Bismillahirrahmanirrahim. Today we are going to cover the lecture number 1, which is about the introduction to the computer graphics. First, let me introduce myself. My name is Murtaza Ali Khan. I am assistant professor in the Department of Computer Science at Qura University. And following is my email address. You can communicate with me using my email address. And I have an office in Building H, first floor, room number 1149. If there is a need, we can set the office hours to discuss anything related to the course, but preferable way of communication is the email address. We are also going to use some learning management system for this course. You will get the information about the system. Most likely it will be the Blackboard. So I am recording this lecture, so this lecture will be available to you by using the learning management system. Lecture will be in the two formats. One is the video file, in which you can listen my voice and I am going through the PowerPoint presentation, and the second format is the PowerPoint presentation itself, of course without the audios, so you can read the lecture slide from the PowerPoint. Now let's discuss about this course, which is Computer Graphic 140125001, and it is the 3 credit hour course. From the course you can know that this is the basic course, introductory course about the computer graphics. So we are going to cover the topics in this course which are the fundamental or the basic of the computer graphics. So the topic we are going to cover is about the computer graphics hardware, some basic information about the hardware such as the screens, tablets and the other devices which are providing the interaction between the user and the computer. We are going to discuss about the two-dimensional object drawing. So how we are going to draw these drawing by using some programs. Of course we have to use some programming language, and in that course we are going to use a Java language. So we are going to learn the mechanism, how we can draw these objects and how we can set the colors and set the line style when we are drawing these objects two-dimensional. There is a classic algorithm in the computer graphics which is called the Brazenham line drawing algorithm. We are going to discuss this algorithm. This algorithm is important in the sense that this was one of the earliest algorithm by which we can draw the line on the screen. Apparently it seems quite easy to draw the line on the screen, but if we look at the algorithm you will notice that you will know that this is not so simple task. We have to set some parameters so that our algorithm is going to be very efficient and using only the integer calculations or the integer computations. So this whole lecture is going to be about the line drawing algorithm. We are going to discuss about the transformations in the two-dimensional and in the three-dimensional. By the transformation we mean that when we draw some object or when we construct some object, then later on we want to apply some operation on these objects. What operation? For example, we can perform the translation of the object. Translation means we are moving the object in the plane or in the three-dimensional space. For example, we are moving the object along the x-axis or maybe along the y-axis, or maybe at the same time moving along the x and the y-axis. Similarly, if our objects are in the three-dimensional, we can apply the transformation in the 3D. So in the 3D we also have the z-axis. One kind of a transformation is the translation, which is about the movement of the object. There are the other kind of transformations are there. For example, like a rotation. By rotation means that we are changing the orientation of the object by rotating to some degree. For example, 30 degree, 90 degree, and we change the orientation of the object. And there are some other transformations are there. For example, like a scaling, changing the size of the object, and the shading, distorting the shape of the object. So a whole or maybe 2 lectures will be about these geometric transformations. So this is quite important in the computer graphics. We will discuss in this course about the computer animations. And the animation is an important topic of computer graphics. So we can create the synthetic movies, synthetic images by using the synthetic images, and which are going to create the computer animation in which the objects are doing some operations, for example translation, rotation, scaling, and doing some kind of actions. We will also discuss about the three-dimensional object drawing, in which we will discuss that how we can draw the three-dimensional object on the computer screen. So in this topic we will also talk about the some kind of projection mechanism, how we can project the three-dimensional real world coordinate onto the two-dimensional computer screen. And remember that our computer screen is a two-dimensional, and the world in which we are living, it is a three-dimensional. So it is it should be there should be some mechanism by which we can transform the coordinate of a three-dimensional world onto the two-dimensional computer screen, and this transformation requires some kind of projection. So we are going to discuss about this topic. We are going to discuss about the lighting or the illumination. If you want to create the realistic images, then the part of the lighting or the illumination is very important. So what are the different lighting models are there, what are the different illumination models are there, and how close they are to the actual lighting, because it might not be possible that we can mimic the lighting of the actual world. So we are sometime making the approximation. So these models are going to discuss about these issues. We are going to discuss about the color models and the applications. Maybe you are familiar with this concept that there are the three basic color or the fundamental colors are there, which are called the red, green, and the blue. So there is a model for this three colors, red, green, and the blue. So we will discuss in this topic that how the combination of these three components are making the color, and what are the space for this RGB model. What kind of shape is there for this model. Not only the RGB model, there are some other models are there which are used in the graphics, not only the computer graphic but and also in the real world. For example, HSV model and CMYK model, which is particularly used in the printing industry. So we are going to cover also these other models also in this course. Let me see that if the recording is going correctly. Yes. So sometime I just want to check that, because I am recording this lecture, so I want to make sure that my recording is going smoothly. So just I switch from the PowerPoint to this recording software. Now let's see about the course learning outcome. So what you are going to learn from this course: once you complete this course, you should have developed some skill. So the following are the four learning outcome of this course. Understanding the foundation of the computer graphics. So we are going to discuss some basics, some fundamental concept about the computer graphics. As I told you, this course is a fundamental and the basic course, so this is very important that we understand the basic mathematics about the computer graphics, and we understand that how we are using this model for creating the model of the different object, either in the two-dimensional or the three-dimensional. So modeling is a important part for this course, and also we are going to cover the topic of rendering. Rendering means that when we have models, some model is there. For example, a model of some object, it may be a car, or it may be a table, or it may be a chair. Then ultimately we have to transform this model onto the computer screen, and this process is called the rendering. So how we are going to perform the rendering, what are the different concepts are there for the rendering, we are going to cover in this course. We are going to see the mathematical background of the computer graphics. Computer graphics is heavily rely on the mathematics and also somewhat on the physics. For example, if we are covering the lighting topic or the illumination, then we have to see some physical models there. So we will see some mathematical concepts are there. We will see some equations are there. We will see that how we are going to use these equations, these parameters to create the model of the different object. So you will have the knowledge about the mathematical background of the computer graphics. And the next learning outcome for this course is the understanding the colors. As I told you that there are the different color models are there. The most frequently used in the computer graphics is the red, green and the blue color RGB model. But as I told you, in addition to these, we are going to discuss some other color models, for example the HSV color model and the XYZ color model. And some of these models are just theoretical model, but they are making the foundation for the other color models. We will discuss them. And the fourth very important learning outcome of this course is the implementation of the computer graphics project. So we are going to have some project in this course. In addition to the project, before the project we have the labs, but the main objective of the lab is to prepare you for the computer graphics project, which should have a substantial component of the programming. So once you learn the basics, how to write the graphics program, then you can use these ideas, you can use these knowledge to build the computer graphics project. So we will discuss the more detail about the computer graphics project later on. But in the project, you may have to create a project which can be related to the some game, and you have to do the complete programming. We are not using some gaming engine. For example, there is some gaming engine is there like a Unity, and by using this engine, it's not difficult to create the three-dimensional games or something related. But if you are writing the program yourself, you are going to learn more, and this is the fundamental course. Our preference is that you write the code for your project. So if it is a game, you have to write the code. It may not be so much sophisticated as if you are using the gaming engine, but this will be the more opportunity for you to learn in this course. So these are the learning outcome for this course. Now let's see about the text and the reference book for this course. In fact, we are not using just one single book. Many books are being used. Some material is being used from the internet, and some material is used from the other resources. So but the three books which I am going to suggest you is the following: Fundamental of the Computer Graphics by Peter Shelley. So this is basically most of the things in the lecture are somewhat dependent on this book. So you can say this is like the first textbook for this course. And the other books are also being used from time to time. For example, Computer Graphics with the OpenGL by the Hahn and the Baker. In this book, basically they are using some other programming environment which is called the Open Graphics Library. Though we are not using the OpenGL, but the book have the advantage that they describe the concept in a simplistic way. So it may be easier for some of the students if they read the book and do not go into the detail of the implementation of the OpenGL, but just to understand the concept, then this book can be a good choice because the language of this book is simple. The next book is the 3D Computer Graphics by the Alan Watt. So this is a quite comprehensive book. So a lot of concepts are being discussed in this book in much more detail. So if someone want to be in more detail, he or she want to dig into the detail, then this book is being recommended. Now let's talk about the assessment methods and how the distributions of the marks are there for these assessment methods. So we will have the quizzes and the assignment, which is 20%, and since at this time when we are living in the situation that our teaching is online, so we are having the quizzes and the assignment 20%. So I am not sure that how we are going to manage the quizzes, because it might not be easy to monitor or invigilate the quizzes by using the online teaching. So there might be assignment, or there might be quizzes, or there might be the combination of these. So this is a 20%, midterm exam is 30%, lab and project 10%, final exam is the 40%, and the grand total is the 100. There might be some change in this distribution. So this is some initial tentative assessment method, and their distribution of the marks are there. So if there is some change, I am going to inform you. Now let's discuss about, because this is the first lecture, first I introduce you about myself, then I give you the overview of the course. I give you the idea about the what topics we are going to cover in the course. I give you the about the learning outcome, about the textbook, and then the assessment method. Now I am going to discuss some basic concept of the computer graphics. So this is the actual part in which we are discussing the lecture 1, which is the introduction to the computer graphic. So I write here topic introduction to the computer graphic. So this is the main thing which we have to discuss in the lecture number 1, introduction to the computer graphics. So what we are going to discuss in this lecture: what is computer graphics, how we define the computer graphics, some areas of the computer graphics. Computer graphics is a big field. There can be the different areas can be there. So we are going to see some important area of the computer graphics. Then application of the computer graphics. Computer graphics can be applied in the real life, in many situations, in many applications. So we are going to cover some of the application. For example, when you see this lecture, there is application for the computer graphics, because I am using the screen capturing software which is capturing the screen. I can annotate this screen, I can write something. So these are the application. I can make this lecture much more interactive and much more interesting by using the computer graphics technique. So we are going to see some of the applications of the computer graphics. Not all the application, but some important application. For example, like a gaming, like a animation, like a virtual reality, like using the computer graphic in the medical imaging. Then we are going to discuss about some basic concepts. These concepts or these terminologies are going to be used again and again. So it is important that you understand them and you have the knowledge of these concepts, so they can be used once they are being used later. You have already have a clear concept about these parameters or these terminologies or these concepts. And then some discussion about the computer graphics API. API means application programming interface. So the different programming languages are available in which we can write the computer graphics program. For example, like a C. And when we are using a C, usually many choices are there. One of the choices is that we are using a library to write our program, and one of the famous and you can say open source library is the OpenGL. So it is a choice. Other choice is that you are using the DirectX, and then another choice is the Java API. Since you are familiar with the Java, you have taken the basic course in the Java, so we are going to use the Java API for writing the computer graphics programs, and of course you have to use the Java for the project. Now let's talk about the what is the computer graphics. Anything to do with the visual representation on a computer. So we are using the word computer graphics. So you have to represent something on the computer. Now when we talk about the computer, we are covering the array of the devices or the large range of devices, not just the desktop computer. It may be a laptop, it may be a tablet, or even it may be a smartphone. So something has the visual representation. It can be the image, it can be the animation. And the next, how we are going to define the computer graphics is that computer graphics is related to something two-dimensional and the three-dimensional. Two-dimensional drawing is a simpler sorry. So we are going to discuss in the computer graphic how we can draw the two-dimensional object on the computer screen. As I told you earlier, the computer screen is a two-dimensional. We are going to also discuss about the three-dimensional, but in the three-dimensional, which is much harder, we have to perform some kind of projection, because the real world is a 3D, and when we are modeling something we are modeling some object of a real world, first we model it into a three-dimensional space, and then we project onto the two-dimensional computer screen. So both the concepts are going to be covered, the modeling and then the projection and the rendering of this three-dimensional model onto the two-dimensional computer screen. So 2D and the 3D graphics and modeling and rendering are essential of the computer graphics. So these are the main things which we have to deal in the computer graphics. Now there are some auxiliary problems are there. Auxiliary means some additional issues are there or additional concepts are there which might not be so important, but familiarity with these concepts might be helpful. For example, like a display devices, if you understand the resolution of the screen, if you understand what is the underlying technologies, the LCD, LED or whatever, then maybe it may be helpful for you to use a better technique of which are being adopted for these kind of devices. And then, as I told you, that math is very important for the computer graphics, because when we are modeling we have to use some mathematical concept how to model the objects, and sometimes we have to use the physics if we are discussing some advanced concept, for example like illumination or the lighting, or maybe some object is falling and then object is bouncing, for example like a ball. So in the different time in a lapse of time, how it is going to be bounced. So some physics mechanism should be there, which may be related to the inertia or maybe to the gravity or maybe the Newton's law. So they are going to be involved also in the computer graphics. Now let's talk some main area of the computer graphics, because this lecture is quite fundamental, the basic. We are not discussing very complex concept, just try to make your interest, try to create the interest, your interest in the computer graphics. So we are discussing some concepts which are not very difficult but might be interested for the student. So following are the main area of the computer graphics: modeling, rendering, animation, virtual reality, data visualization, and the image processing. Now we are going to briefly discuss roughly 1 or 2 slides about each of these topics, mostly 1 slide for each of these topics, so you will have some idea about this area of the computer graphics. So first is the modeling. So we write here the main heading is the area of the computer graphics. So within the area, our first area which we are discussing is the modeling. And as I told you that this is not the exhaustive list, this is just some main area of the computer graphics. There can be much more than these lists. Modeling, also known as the meshing, is the process of developing a mathematical representation of any three-dimensional surface or the object. So when we talk about the modeling, we have to use some mathematical concept how we are going to model this object. Either we are using the vertices, or we are using some edges, or we are using some points in the polar coordinate with some angle. So we have to model some object. So it is not that we are drawing with the brush and the pen and we can draw anything. When we have to draw very precisely, then we have to come with some mathematical solution. So later on we can easily apply some operation on these models. For example, as I told you, that like a transformation operation, like a scaling. So if we know what is the mathematics behind this thing, so we can use these mathematical equations to apply the scaling. We can change the size of the object. Maybe we can increase the size or we can reduce the size, because underlying things are the mathematical model. So modeling is the process of developing a mathematical representation of a three-dimensional surface or the object. Here we have written three dimension, but of course 3 dimension is the most relevant to the real world. But also this involves the 2 dimension. Even if you want to draw some simple object, for example, if you want to draw a rectangle, you need a model. What is the model means? Maybe you can draw the rectangle by specifying the top left corner, and you are specifying the x and y coordinate. Then you specify the width, and then you specify the height of the rectangle. So basically you create the model of a rectangle by using the 4 parameters x and y, which are the coordinate for the top left corner, then the width and the height for this rectangle. So once these 4 parameters are available, we can draw the rectangle on the screen at the position x and y with the width w and the width height. So this is the one way for modeling the rectangle, but there can be some alternative way. So this maybe you can say a good way, or maybe a very compact or precise way to model the rectangle. But alternatively, maybe you can specify the points at the 4 corners of the rectangle: P1, P2, P3, or maybe we write here P3 and then P4. So we can create the rectangle if we specify the 4 points or the 4 vertices of this rectangle, and every vertices has the two coordinate x and y for the p1, x and y for the p2, x and y for the p3, x and y for the p4. So you need the 8 values. Here you need only the 4 values, x, y, w and h. But this can also be another way for modeling the rectangle. So for the two-dimensional object, the modeling is a simpler, but for the three-dimensional, more sophisticated models are being required there. The next area of the computer graphic is the rendering. So within the area of the computer graphics, we are discussing about the rendering. Rendering is the 3D computer graphic process of automatically converting a 3D wireframe model into the 2D images with the 3D photorealistic effects on the computer. So when we create the model, our essence or our main idea is that we are creating a mathematical model, but ultimately when we are talking about the computer graphics, we have to display this thing on the computer screen. So when we talk about the rendering concept, we have to transform this this original 3D mathematical model onto the two-dimensional computer screen. So basically we are creating the 2D image because the computer screen is a two-dimensional, so they need a kind of projection is there. So this is basically the rendering. But usually when you are creating a model, you are not going to be much more concerned about the colors and the texture of the object. You are just giving the idea about the physical shape, what are the vertices are there, what are the edges are there, what are their positions are there. But when we transform these 3D model onto the computer graphic screen, then we are also being interested in creating the colors and the texture of the object. So rendering is also involving these concepts. In addition to transforming the 3D model, mathematical model onto the 2D images, but also creating texture and the color for these models. Texture means that maybe some objects are like a wooden texture, some object may have a metallic texture. So in the rendering we have to see these parameters. So initially a model is created like a structure which is called the 3D wireframe. Then finally when we are going to display this thing on the computer graphic screen, we can have a variety of options for changing the texture or choosing the color of these objects. So this is the rendering process. The next area for the computer graphic is the animation, and this is an interesting topic because many movies are using the animation. CG effects are very common in the movies. So when we are creating the animation, basically we are creating the illusion of the motion through the sequence of the images. So basically the animation is a sequence. Images are there and they are in some order, and when we are drawing these images at a certain speed or at a certain rate, for example 25 frame per second or 25 images per second, or maybe at a higher rate 60 frame per second or 60 images per second, then due to the persistence of vision phenomena, the human mind is going to perceive them as a motion. So basically they were the sequence of the images, but since they are being displayed with certain rate, so the human mind is going to perceive them as a animation. For example, we can say that this is the image number 1, this is the image number 2, and so on and so forth. 1 2 3 4 5 6 7 8. So we have the 8 images are there, and if we are going to make these images in such a way that the motion is gradual, not very rapid, or not certain distortion is there in the motion. For example, if the person is walking, then the body or part of the person, for example his legs and his hands, are gradually changing the position. And when these images are being displayed on the computer screen one by one in the right order, in the right frame rate, and at the right frame rate, then this is going to create the illusion of the computer animation. Of course, here I just show you the 8 images, but in the actual animation you need the thousands of images are being required there to create the animation. For example, if you just want to create the animation of 1 second and your frame rate is 25 frame per second, so it means that you need the 25 images just for 1 second animation. So for 10 second animation you need the 250 frame of the images. So you can think that if we are going to create the animation for 20 minutes, how many images are going to be required there. So it might not be so much easy for the human to create these animations. So computer graphics is going to provide the mechanism or the algorithm by which we are going to specify some importing or the keyframes images, and then computer is going to generate automatically the intermediate frames or the images. The next area of the computer graphic is the virtual reality, something which is not real but virtual but looks like so real. So this is called the virtual reality. Allows the user to interact with the computer simulated environment. When we talk about the virtual reality, the idea or the concept is that human being is going to interact with some environment which is a virtual environment, but this human is going to think that he is in a real world, and he is not just sitting outside this world. Like I'm sitting here, I can see the computer screen, but I'm not doing anything physically manipulation of this world. But when we talk about the virtuality, the person who is interacting with the virtual world, he is going to do some actions, and these actions are going to be transformed into something which might be interested for this person. Maybe he is playing the game, or he is visualizing some environment. So if he is playing the game, maybe he is moving the hand, and his motion of the hand is going to throw some ball, or maybe he is hitting some object, or maybe he is driving the car. So he is going to think that he is a part of this environment. His actions are being transformed into the virtual world. So this is the concept of the virtuality. Of course, for the virtuality you need the a special kind of equipment. Maybe you need the digital walls, maybe you need the special kind of glasses, or maybe you need the special kind of gloves, or maybe some helmet by which you can interact with the environment, because it needs some kind of sensors which are going to get the data from the human, and then using this data to manipulate some object into the virtual world. The next area of the computer graphic is the visualization. Data visualization is the study of visual representation of the data. If the data is in the format of the numbers, maybe it might not be easy for the people to understand this data, or to get the summary of this data, or to get the overall idea of this data. But if you are going to represent this data in the form of the images, then it might be much more helpful for the human being to understand this data and can have a quick look over the data. For example, if the data is about the weather, then by showing the different part of the world or the earth by the different colors, we try to mimic that what weather is there. Maybe weather is the windy, or the cloudy, or the hot. For example, for the hot, there may be the different level for the temperature. If the temperature is going to be high, our intensity for the red color can be high. But if the temperature is lower, then the intensity is going to be reduced. So by just looking over the map, one can understand, or one can grasp the idea that what kind of weather is there. Either it is a very hot, or the moderate, or the temperature is the low. So this is a one way for visualization of the weather data by using a computer graphics. Other maybe is that most of us are using the Google map. Think about that. Without the Google map, if the instructions are just like in the format, go straight 1 kilometer, then turn right, then turn left, then go again for 0.5 kilometer, like this thing. So it might not be very helpful, or might be difficult for the human beings to follow these maps. But if the map is going in the format of the graphics, if you can see the streets, we can see the navigation path, and we can see the nearby places, then it might be much more easier for the humans to follow this map and then go to the destination. So what we are doing, the actual data, which might be the coordinates or some numbers, transform this data into the visual representation, so which is easier for the human being to use this data. So this is the area of the data visualization. I give you just two examples. One is about the weather, and another is about the map. But there can be a numerous example for the data visualization. Maybe now social media is there. We can perform some kind of sentiment analysis, in which we can know about the sentiment of the people and then represent them by using the graphical ways of these sentiments. So this will also come under the topic of the data visualization. The next topic is about the next area of the computer graphic is the image processing. Image processing is a technique in which the data from the image is digitized and various mathematical operations are applied to the data. First we are performing the digitization uh, of the picture or the scene. For example, if we take a picture from the camera, then what we are doing, we are actually we are taking the picture of the real world and saving this this picture in the form of the pixel, and for every pixel we have the color values are there. So what we are doing, actually we are transforming the real world into the digitized format, where we have a special location of the pixels are there, and for each special locations there is some intensity values are there. So this is the digitization process there. But this is not enough. Just we take the picture from the camera and save them as a PNG format or the JPG format. These are the digital formats are there, but we might need some other operation on these images once they have been digitized, to get the better idea about the image and maybe to extract some knowledge from the image. So that's why we are saying that image is digitized and various mathematical operations are applied on the digitized image to the data means to the digitized image, in order to create an enhanced image that is more useful to perform some of the interpretation of the recognition task. Here we are saying the recognition task, but when we are applying some operation, there can be some other task can also be done by using the image processing operation. For example, here in this picture you can see that there is a digital image is there, and by using some image processing, what we have done, we have obtained the outline or the boundaries or the contour of these image. So you can see that they are showing the only the outline, so we can have an idea about the structure of the different objects which are there in the image. So these structures are important. For example, if you are writing some machine learning algorithm, and nowadays you know that machine learning and artificial intelligence are quite hot topics, then we need some image processing operations are there, so the machine learning algorithm can understand that what kind of this object is it. For example, once we obtain the contour or the boundary, we can know that what kind of object is it. For example, is it a car, is it an automobile, is it a human being or something else. Then we can make our decision, the algorithm can make the decision then what to do in that case. So image processing operation make it easier for the recognition task of the object or the human, and then make some decision. So this is a one possibility of the image processing, but there can be some other possibilities can be there. Sometimes we want to remove the background, just we want to see the object in the foreground, and we want to classify the objects. Maybe the three different kind of objects are there, and we want to categorize them into the three classes. So we are going to perform some image processing on the images. We have discussed about the areas of the computer graphics. As I told you, many areas are there. We have just covered few basics. Now we are going to discuss the application of the computer graphics, where the computer graphics can be used. What are the different fields are there? Of course, these two things are somewhat overlapping. For example, if I say areas of the computer graphics and the application of the computer graphics, from the areas you can have the idea of the application where it can be used. So this can be overlapping, things can be there. So now let's see some of the application of the computer graphics in the graph and the chart, simulation, CAD/CAM. We will discuss what is the meaning by CAD/CAM, medical imaging, and the games. So let's discuss them, each of these applications one by one. So first application for the computer graphics we are discussing is the graph and the chart. Graph and the charts are commonly used to summarize the financial, statistical, scientific, and the other type of the data. So by using the computer graphics, we can transform the data into some graphs and the chart. And especially if you want to come out of the overall idea or the summary, then these graphs are quite helpful. For example, for the expenses, we can divide them into the different areas, and each area can be represented by the different color, and there can be percentage can be written here. For example, this is like a 40%, this is like a 30%. So we can know that how the expenses are being distributed in the different area. So just have a quick look, we will have the idea about this thing. This may be application in the financial or maybe in the other sectors. Similarly, for the scientific data, there are some physical phenomena are going on. Either the heat is, either the temperature is changing, or the heat is moving from one part of the object to the other part, from one body to the other body. There is some there is some radiation, there is some convections are there. Then these phenomena can be represented in the visual format by using the graph and the chart. So this is a kind of three-dimensional representation of some scientific data. Of course, we have a simple kind of graph like a bar graph or the line graphs are there which can represent the data. This might be the performance of the different people or different commodities. So we can see that, for example, on the stock we can know that either the stock prices of certain commodities increasing or fluctuating or decreasing. So graphs and the charts have a numerous applications, and maybe some of you have already used that in the Microsoft Excel. We can easily convert our data into the graphs and the charts. The next application for the computer graphic is the simulation. What is a simulation? A computer simulation is a computer program that attempt to simulate an abstract model of a particular system. So usually sometimes it happens that it might be difficult to generate the actual world or to create the real world with the availability of the tool and the data. So what we do, that what data we have and what tools we have available, by using these data and the tool we create some kind of artificial environment or the artificial model of something. This can be the model of a, for example, like a weather model. For example, if we have to do the prediction of the weather, and you know that the weather prediction is very important for the various reasons. For example, for the flight operations and for the people who are working in the rescue field. If the temperature is high, maybe there may be more call to the 911. So we need the data in advance. So for example, what might be the weather tomorrow, what will be the weather tomorrow, what is the day after tomorrow, or what may be in the next week. So how to get this data? We don't have this data, but what we are going to do, based on the existing data of the current week or of the last week or the week before the last week or even before a year, we can create a computer algorithm which are going to predict the weather of the future, of the next day or the next week or maybe 15 days. So based on this weather we can make some decision and we can do this thing. So this whole thing is called the simulation. So a lot of data is being used in the simulation. We are processing this data which is available there and then usually trying to create a predicted data. One kind of simulation is there, one example. The second simulation is that sometime if we have to perform some operation which might be expensive sorry, or which might be danger to perform in the real world, then we can create a simulated environment. For example, if we have to perform the training of the pilot, the people who are flying the aeroplane, so just directly allowing some person to sit in the cockpit and then fly this plane can be dangerous and can be expensive. So we can create the environment in which a person is sitting in artificial environment where the haptic devices are there which are getting the feedback in terms of the motions using the sensors, and there is some kind of screen is there, some panels are there and some control panels are there and some controlling devices are there. And then the training pilot can use this environment to fly a plane which is not the real plane but in the artificial environment, in the artificial world. So this is going to be the simulation, but to generate this simulation we need a lot of data about the environment, data about the different object, data about the different components which are being used in the aeroplane, and then how to represent this data in the graphical format so they are going to be look quite similar to the actual aeroplane. So this is a kind of simulation is there. So this is a difficult but important field of the computer graphics. The next application for the computer graphic is the CAD and the CAM. CAD means computer aided design. So we are designing with the aid of the computer. Computer is aiding us, helping us, assisting us. And the second is the computer aided manufacturing. So either we are performing the design or we are performing the manufacturing So if we have a facility for the computer graphics and we can visualize these objects, then it might be easier to use these devices for the designing and for the manufacturing purpose. For example, if you want to design a car, then it is a good idea that when we have some software by which we can design a car, and then we can look the model of this car on the screen from the different angle. We can perform the rotation, we can perform the scaling, we can change the orientation of the car, we can rotate 360 degree, and then if some modifications and some things are being required there, we can perform this thing on the design at the design stage, because it might be difficult later on once we have manufactured something, then to change in the design and again manufacture. It might be costly or it might not be feasible. So once we are satisfied with the design which we can visualize and which we can edit, then it is a good approach. So this is being used in the computer aided design. Not only the car but many objects, even the simple object, for example like a chair, like a mobile phone, like even the mouse, keyboard, they can be designed by using the designing software. Similarly, if we are manufacturing something, so companies have the machines are there, they are manufacturing the different objects or the different products. So if we are controlling this manufacturing by using some software, then the person who is operating on these machines, if he has the software, he can control the things much more accurately in a much more convenient way. So how to cut the different component, how to use the different machinery to create a different component by using the software, it can be a relatively a better or easier task, or the easier way to do this thing. So in the manufacturing industry, softwares are being used to manufacture different products which can be visualized, and we can modify the different parameters by using these softwares. So CAD and CAM methods are now routinely used in the design of the buildings, automobiles, aircraft, spacecraft, computer, textile, home appliances and the other products. So both of these are being quite commonly in the industrial sector. Another important application for the computer graphic is the medical images. We want to use the computer graphic for the diagnosis and for the treatment of certain diseases. Most of you are familiar with this thing. We can use the X-ray imaging technique to get the X-ray of the human and can know that how are the bones are being connected, or if there is some problem, there is some fracture, or maybe someone has swallowed something. We have to identify this thing, maybe a coin or something metallic object. So we want to locate the position of this object and then maybe perform some surgery or some other thing to remove that object. So this is the important application for the computer graphics. So we can generate a lot of images by the different technique. X-ray is not the latest, it is a quite old techniques are there, but now I think that many of you are familiar with that. Other advanced imaging techniques are available there. For example, CT scanning is there and the MRI are there. More sophisticated machines are being used, even which can generate the three-dimensional model of the human body. They can visualize the different part of the human body, and maybe the internal part and even the tissues can be visualized by using this advanced technique. So for the medical professionals, they are very helpful. They can perform the surgery and these things by using this thing. And in many situations when we are performing some surgery, we are using the camera, and then by using some kind of wire or something connected which we can insert into the human body, and we can insert the camera into the body, and we can know that where the problem is lying. For example, if you want to know that is any problem there in the stomach or in the colon, then colonoscopy or some other techniques can be used, in which we are using the camera and which is providing the picture to the doctors, and by looking at the picture on the computer screen, they can identify the issues are there. So a very constructive application for the computer graphics there in the medical imaging. Next application is the gaming. Maybe you are have much more knowledge than me about the games. So in the gaming, computer graphics are being quite heavily. Most of the games are just the The more important thing about the game is the using of the computer graphics. So as I told you that nowadays very sophisticated gaming engines are available. You don't have to write the code from the scratch. By using this engine, you can automate many processes. You can define the different states, how these states are being connected, and how you can apply the built-in, how you can insert the built-in character or the motion from the motion capture data and to create your games. This is just one example. Subway Surfer is an endless runner mobile game co-developed by Kilo and Cybo Game private company based in Denmark. It is available on Android, iOS, Kindle and Windows Phone platform and use the Unity game engine. So as I told you that gaming engines are available. So if some of you are more interested in the gaming, they can experiment with the gaming engine. But this is a bit advanced topic. Once you understand the basics, then you should go for the gaming engine to develop the game. And this is a quite big industry. So I'm not sure that most of the applications which are being downloaded on the Android devices are the gaming. I think that. So you can imagine that a large number of people, or it is a big industry, are involved in this gaming. Until this slide, which was the slide number 21, we have discussed some basic or the fundamentals about the computer graphics to make your interest in the graphics, that a computer graphic is an interesting field. Now after this slide number 21, we are discussing something not very maybe basic but a bit advanced level. They are not very complex but something more fundamental to understand the underlying concept of the computer graphics. Some of you are already familiar with these concepts, so let's understand these concepts, basic concepts. First we are discussing about the vertex and the edge. Vertex usually we call the word point, but a better word is which is used in the graphic is called the vertex, the common end point of the two or more line segment. For example, you can see that I can say, for example, this is the line 1 and this is the line 2. They are connecting at this point, so this point is called the vertex. For example, if I ask you the question that this is a triangle, how many vertices are there? Most of you will quickly answer that there are the 3 vertices are there, vertex 1, vertex 2 and the vertex 3, and these are the points where the two line segments are being joining. So for the two-dimensional object, it is easier to identify visually, to know visually, and then tell how many, and then answer how many vertices are there. But for the three-dimensional object, a better visualization or imagination is required, that because I'm going to show you the three-dimensional object on the two-dimensional screen, then you have to tell me that how many vertices are there. Before I tell you the answer, look at this picture and then tell me how many vertices are there. Just moment, I will pause for a moment, think about it. I will tell you the answer. How many vertices are there? I think that many of you answer right. In this there are the 8 vertices are there. How? The 4 vertices are at the top, 1, 2, 3, 4. So similarly the 4 vertices are at the bottom. Of course we cannot see the back of this cube, but of course there are the 4 vertices are there. So back side is also like a front side. Of course I'm drawing from the mouse, so my drawing is not very perfect, but the 4 vertices are at the top and the 4 vertices are there at the bottom. So there are the 8 vertices are there in this three-dimensional cube. Let me try to erase this thing. Yes, I want to erase. I talk about the vertex. Now let's talk about the edge. What is the edge? A line segment that join the two adjacent vertices in a polygon. So what is the edge? A line segment that join the two adjacent vertices. For example, if you look at this picture, this is the edge and this is the edge. So the two edges are there. If I show you the triangle in the two-dimensional, how many edges are there? Of course we have discussed previously that the 3 vertices are there. These were the vertices 1, 2 and 3, and also the 3 edges are there. For example, edge 1, which is this edge, edge 2, for example, this edge, and the sorry, let me delete this thing. Again I will draw. So just I will show you the edges. So we have the edge 1 which is from here to here, the edge 2 which is from here to here, edge 3 from here to here. So the edges are between the two vertex. Any edge is there between the two vertices. So in this case the case is a simple. We have the 3 edges are there and the 3 vertices are there. Now if ask you the question that for this 3-dimensional cube how many edges are there, before I tell you the answer, think, and then I will tell you the answer in a moment. So for example, I can say that there is the edge here first, there is the edge here second, there is the edge here third, there is the edge here 4. If I write the number 1 2 3 4, so there are the 4 edges are there at the top. Similarly there should be the 4 edges at the bottom, but in addition to these 4 edges which are at the top and the bottom, there are some more edges are there. For example, there is the edges here. So if I say that 4 is at the top and 4 edges are at the bottom, in addition to these 4 top and the bottom edges, there are the edges are here. One edge is there, one edge is there, one edge is there, and one edge is also there which is not visible, but of course this is a 3-dimensional object, so this edge should be there. So 4 edges are there in the area or in the space which is connecting the top part with the bottom part. So we have a total 12 edges are there. So in this figure there were the 8 vertices was there and there are the 12 edges are there. So it might not necessary that for every object the number of vertices and the number of edges are equal. For example, in this triangle it was a simple case. We have the 3 vertices and the 3 edges. But in case for this cube, the number of vertices are 8 but the number of edges are 12. So this is the concept about the edge and the vertices. So when you look at some object, you should have the ability that you can visualize and you can know that how many edges and the vertices are there of this object in the 3D. One more thing which is not written here is about the face, but here it is written that this whole part is a face which we are talking about for the 3-dimensional object. So this is the whole thing is a face, so I can say this is like a face 1. Similarly there is a face 2 and there is a face 3, but for each of these faces which are being shown, because we are looking in on the 2-dimensional screen, there is a face on the other side. For example, for this face there is a front, so there should be a face on the back side, and since there is a face on the top, so there should be a face on the bottom side. If there is a face on the right, there should be a face on the left. So the total number of faces are there 6. So this is one more concept is there which is not written here, vertex, edge and the faces. So we have the 6 faces are there for this cube. And maybe you know that there is a game which I think we called it Ludo, in which you throw a dice. So you can see that there are the 6 faces are there. The next concept is about the pixel. A pixel is a single point in a raster image or the smallest addressable screen element in the display devices. Basically the concept of the pixel is used both with the image and with the screen. So when we talk about the image, we say that image consists of the pixels, and each pixel will have some associated color values or the grayscale value is there. If you are talking about the red, green, blue, then there is a RGB value for each pixel. If there is a gray, there is a gray level is there. So this is about the image. But the term pixel is also used for the screen. When we have a screen, there is a certain resolution is there. How many pixels are there for the screen? What is the horizontal resolution and what is a vertical resolution for the screen is there. So the each smallest element on the screen is called the pixel. So you can see here we are showing the two pixel, one in the blue color and one in the red color here. But if we are going to enlarge this thing, you can see that there are many neighboring pixels are there. So this whole thing is called the pixel. So we have a red pixel in the blue color, and we have the pixel in the red color. So for every screen there is some resolution is there. For example, we can say that if you buy a computer monitor on the screen, you have the idea that higher the resolution, better will be the quality of the image is there. So when we say the word higher the resolution, means the number of pixels are quite high. So there can be the different resolutions can be there. For example, resolution may be like a 720 multiplied by 10, I think 80. So there are some standard resolutions are there for the screen. So what it means that horizontally for each row there are the 1080 pixels are there, and then for each column there are the 720 pixels are there. So this thing is called the row if you are moving in a horizontal direction, and this thing is called the column when we are moving in the vertical direction. So the total number of pixels for this screen will be 720 multiplied by 1020. So this is, maybe you can say the width, and maybe you can say this is like a height. So usually we prefer that number of pixel along the width are much more larger than the height, then it is going to be create the better view for the human, because we prefer to see something on the screen in the landscape mode where the width is of the screen is higher than the height of the screen. And I say that there are some standard resolutions are there, and it's better that when you are creating some synthetic image or you are creating the videos, you try to create the image or you create the video in the standard resolutions, for example like HD or the 4K, whatever the resolutions are there, you have to choose them. The next concept is about the rasterization. What is the rasterization? Rasterization is the process of converting the object from the vector format to the raster format. Vector format means that when we define some object, we define it by using the maybe the points, or by using the vertices, or by using the edges. So this is the vector format. We have to convert this into the raster format, into the pixel. So this process is called the rasterization, to display on the screen or to print or to store it. Because mathematically we can define some object by using the vectors, by using the vertices and by using the edges, but when we have to draw this thing on the computer screen, we have to explicitly choose which pixels are going to be used to draw this object. For example, mathematically we can draw the line by specifying the 2 points, for example the P1 and the P2, and every point has a 2 coordinate, x and the y. For example, I can say that for the P1 I have x1 and the y1, for the P2 I have x2 and the y2. So this is representing the line using a vector format. I represent the line by using the 2 vertices or the 2 point with the coordinate x1 y1 and the x2 y2 respectively. But when I want to draw this line on the computer screen, I must have to choose the pixel which are going to be used to draw the line between the 2 points. This process is called the rasterization. So here you can see that when we are drawing the line from the vector to the raster format, there might be some loss of the accuracy, because when you represent something in the vector format, when you transform into the pixel, you might lose some accuracy because the screen resolution is not the infinite. When you have values which are in the, especially in the fractional or in the decimal format, then sometimes you have to perform the round of operation to choose the corresponding value in the integer. So the line which might be a perfect straight line in the vector format, when we transform it into the onto the raster format, onto the pixel, then this might not look like a straight line, and this phenomena is going to be much more visible if your screen resolution is the low. That's why it is said that if resolution is the low, the quality of the image usually degrade, because the reason is that when we are converting our object from the vector format to the raster format, we are losing some precision. Similarly, when you are converting some circle which is a perfect round to the to the pixel, you can see that we are choosing the pixel in the blue color, and which are not very perfectly wrong. So you might see some jaggies because of this rasterization process. Usually, because nowadays the resolution of the screens are quite high, so we do not very clearly see these jaggies effects in the rasterization process. But I say that if the resolution is low and original image is being using the high resolution, if we draw on the low resolution device, then you are going to feel this degradation or the jaggies effect. Sorry. Next concept is about the color, RGB color model. We are not discussing the color model in much more detail here. We will discuss it later on. Right now we are just discussing that a color is created by combining the three primary color, red, green and the blue. So you can see that the original image, every pixel will have the three values, the red, the green and the blue. But we can separate out these channels. They are also called the channel, the green channel, the red channel and the blue channel. But when we are combining, we are creating the actual image. But in fact, this actual image is composed of the three channels, which are called the red, green and the blue. So when we are storing the value for a single pixel, we have to store the three values: the value of a red component, the value of a green component and the value of a blue component. And by combining these three values, we are creating a color which is a single color. So they can be combined in a different combination. If the portion of the red is high, then we are moving toward the red channel. If the portion of the green is high, we are moving toward the green channel. So we have to choose the pixel value according to this model. There is slight mistake is there. You may have to correct this mistake. The word is here, not the rasterization. Here we are talking the topic about the texture. So this concept is about the texture, not rasterization. Texture is defined as a function of the special variation in the pixel intensities or the gray value. First look at that. What is the meaning by the texture? What is the concept behind the texture? By the texture, we try to understand that what material is used to make this object. For example, here the texture is much more like a wood, and here the texture is much more like a paper. So the different object may have a different texture. In the real world, we can also feel the texture. We can touch the object and we can feel the texture. Either it is a wooden texture, it is a paper texture, or it is a metallic texture, or it is a plastic texture. But in case for the computer graphics, it does not matter we touch the screen or we do not touch the screen. We cannot feel the texture. So we have to create a texture by using only the colors. So basically we are saying that texture is being created by changing the color value of the pixel in such a way they are creating a kind of look of the texture. For example, as I say that they like a wooden texture. So this is just the color values are being selected appropriately, so they are being creating the wooden or the paper textures are there. Based on the texture properties, we can identify the variety of materials such as the wood, cotton, canvas, other things. So this is the concept about the texture. As I told you that slight correction is required there, you have to use the word texture there. The next concept is there, transparency. What is the transparency? Transparency is the physical property of allowing the light to pass through a material. So when we have a transparent object, then the light can pass through, and when the light can pass through, we can look what is there in the background. For example, for this image, you can see that on the image which is on the front, we are writing some text, but there is some image on the background which is the flowers are there. But this image which is at the foreground where the text is there, we can also look there what is on the background, because this image is using some kind of transparency. We can choose a different level of the transparency, not 100% transparency. If the 100% transparency is that, then the foreground object will not be visible. So you have to choose the transparency. Maybe you can say that the transparency is like a 50%. So then you can see the foreground image and you can also see the background image. So if you want to see the background image behind the foreground image, then you have to use the transparency value with the image. Now the additional concept is there before this slide. We have discussed that for every pixel we are storing the three values, the red, the green and the blue, for every pixel. Now if you are using the transparency, then for every pixel you have to store the 4 values: the red, the green, the blue, and the alpha channel, which is representing the transparency. So you have to specify the 4 value for the every pixel, and this value is going to define that how much is the transparency is there for this pixel. If you are performing the normalization of these values and assuming that the values are between the 0 and the 1, for example, the red can be like a 0.4, the green can be like a 0.3, the blue can be like a 0.5, and the transparency can be like a 0.5, which is like a 50% transparency. So we are choosing the value between the 0 and the 1. Every value is there between the 0 and the 1. So these values RGB they are deciding about the color, and the alpha value is deciding about the transparency. A transparent image is one whose background allows the page background to display through. As I told you that you can look at the background if the image is the transparent image. The next concept is about the shading. Shading refers to the process of altering the color of an object in the scene based on its angle to light and its distance from the light to create a photorealistic effect. In the computer graphics, if you want to create a realistic image, realistic image means that which looks like an image in the real world, then you must have to use the light or the illumination. When you talk about the light, then you have to be careful about the two things. One is that what is the source of the light and where this source is located. Maybe the source is located on the right or maybe on the left. So the illumination of the object is based on this source, on this source of the light. So if the object is coming directly under the source, it will be more illuminated. But object is not coming under a direct directly under the light source, then it might not be so much illuminated, but still it will get the illumination which is in the room. And the second thing is that you also have to see that what is the distance between the light and the object. If the light is closer, object is going to be more brighter or illuminated. If the light is coming far away from the far away distance, then the object might not be very illuminated. So in these two images you can see that some part of the image or the objects are more illuminated because they are coming directly under the light source. So for example, I can give you that this part is more illuminated but this part is a dark. So we can say that light source is somewhere here. And similarly this part is a dark because this is something which is not coming directly under the light. So the part which are not coming directly under light, they are not much illuminated. So shading has to be created by considering the source of the light and also the position of the light source and the distance between the object and the light source. Next concept is about the wireframe model. A wireframe model is a visual representation of an object. So we are presenting the object by defining its model in terms of its structure by using the lines and the edges or by using the curve and the vertices. It is created by specifying each edge of the physical object where the two mathematically continuous smooth surfaces meet. When usually you are drawing the object which is in a shape of the cube or the rectangle, you are using the line. But if you are drawing more sophisticated object, then in addition to the line you have to use the other mathematical component, for example like a curve. For example, if you want to create the sphere, you have to use the curves. So this curve is moving, and similarly we have the other curve is there. So we are moving the curve, and then along the, maybe you can say along the x-axis, and then also we are moving the curve along the y-axis like this thing. So by using these curves we can create the structure or the shape of the object, and this shape is called the wireframe model. As I told you that the first job in the computer graphics is that first we create the mathematical model of the object. You can create the mathematical object by using the graphic primitive such as the points or the vertices or the line or the edges or the curves or maybe the like a basic shape like a triangle. And once these models or the wireframe models are being constructed, then later on you can apply the texture and the color to these models, because usually what happens that modeling is the more important thing, and we want to create the model once, but later on the texture and the color can be applied many times, and then we can decide that which texture is more suitable or which color is more suitable for this thing. For example, for this car, once we create the wireframe model, then later on we can apply the texture of the red color, metallic texture in the red color or maybe in the blue color, and then we are going to look, or we are going to visualize how this car will be look like in the real world. Underlying wireframe model is not going to be changed, only the texture and the colors are going to be changed. So the wireframe model is like a building block or a structure of the object. And now let's discuss about the graphics API, application programming interface. When we have to write the graphic program, we have to choose some programming language, and the programming language provide us a kind of interface by which we can look at the libraries, and we can decide that what classes are being used, what classes we can use, what method we can use to write the graphic program. So if some classes, some methods are already available there, we prefer to use these because these are the standard classes are there. And something which is not available there, we write our own code for this purpose. So most of the languages are going to provide the API in which there is a part which is related to the graphics. So when we have to do the lab or you have to do the project, you have to write the graphic program. So I told you that the different choices are there, such as that using the OpenGL, which is the Open Graphic Library. Implementation for the OpenGL is available even for the Java, but mostly it is used with the C language. Other choice is using the DirectX, which is the Microsoft technology, but we are going to use the Java 2D and the Java 3D to write the graphic program. So let's see what is written here. API is a software interface that provides a model for how an application program can access the system functionality, such as drawing an image into the window. So by using this API, you will know that what constructor, what classes, what method you have to use to draw the object, how you can change the color, how you can set the thickness of the line, and other things are there. The most APIs have the user interface toolkit for some kind of user uses callback. So they are providing a toolkit. User toolkit means that they are providing you the method, and the method have the input parameter and the output parameter. Each method has a signature. So you have to write the name of the method, and you are going to pass some parameter. Method is going to process these parameter and then going to produce the result, and which are going to be returned to the calling function, and then we can use these parameter to adjust or to draw the different things on our program. As I told you that different APIs are there, we are going to use the Java 2D and the 3D programming. So when the lab component will start, you will know more about this thing. So this is the end of all this lecture, introduction to the computer graphics, and references are there. I write just the main reference, fundamental of the computer graphics by Peter Shelley. There are other references are there. So for example, like Wikipedia references are being used there. So you can look at the textbook and the reference book, and finally the disclaimer and the fair usage statements are there. So thank you for listening this lecture.